Good morning, everybody. Thanks for joining Chris and I this morning. I am the owner of Pipe Reline Solutions. We are a pipe consulting company. We come in, look at different options for different relining projects, whether it's pipe repair or slip lining. In this case, we're talking to Chris MacDonald, who's the owner of CPM Pipelines. And we actually just brought on their product line, this kicking off 2023, called the BulletLiner System for pressurized pipes. So this is new for us. We've always kind of focused on stormwater and gravity pipe. So it's exciting to add a pressurized lining system to our toolbox. And with that, Chris, I'm going to hand it over.
Hand it over to me. Well, thank you for having me. I appreciate it. I'm excited to get a chance to talk to you, kind of let the Northwest and the rest of the country know that we're teaming up and partnering up to, as we introduce the BulletLiner flexible fabric reinforced pipe system across the country, and looking for valuable partners like yourself and your team across the country. So I feel pretty fortunate and lucky that you've decided to come on board with us.
Yeah, we're very excited. So with that, you're going to show us some slides. I probably need to let you have the screen access, right?
Sure.
Okay, let's make sure you can host it. All right, you should be able to share your screen now. So as Chris gets started, if anybody has questions, go ahead and put them, either raise the hand or use the Q&A box. I'll be monitoring that. We can also open it up at the end. People can unmute themselves and we can do live questions. I try and keep these short, right at 30 minutes, just so we don't take up too much of your guys' time. Yeah, so I'll let Chris kick it off.
All right, let me see if I can get this in presentation mode instead of where I'm at. Here we go. All right, I think we're all set. Does that look correct?
Yep, looks good.
All right, so again, thanks, Cassie, for having me. I appreciate it. Any chance we get to, team up and market this stuff together and work together on LinkedIn or the different platforms we use is really awesome. And there's a lot of new ways to do that now. So we're really excited about it. To see that you and your company kind of is looking at this stuff the same way we are is fantastic. So yeah, today what I wanted to come on and talk about, and hopefully Cassie will ask some questions as we go along. And if there's anybody else that has questions as we go along, that'd be great. So my name's Chris MacDonald. Like she said, I'm the president and CEO of CPM Pipelines. We've been in business about 13 years now, I guess. And we really started focusing on the pressure pipe and pressure pipe inspection and pressure pipe rehab aspects of the business probably close to 11 years ago. We were actually one of the first companies in the United States, or the first company, to introduce flexible fabric reinforced pipes here in the United States. And we've done probably close to 100 projects since then. And then just recently kind of captured an opportunity probably about 6 months ago to be able to introduce basically our own line of FFRP products into the United States with a lot of different options for performing these types of pressure pipe rehabilitations on, water systems, sewer force mains, gas mains, high temperature pipes, oil and gas and hydrocarbon type material types or media types as well. So it's been really exciting. We're able to get out across the entire country now and kind of leverage all the relationships and friendships and business people we've been doing business with for 12, 13 years. So we're really excited to be able to do that. What we do is kind of a unique combination of different things, but what's really unique about CPM Pipelines, I think, compared to a lot of other companies in this space, is we offer not only the inspection technologies, but we also offer the rehab solutions. So, today we're going to just talk about the rehab solutions, specifically the BulletLiner system. But what's interesting is we're able to go out actually and do inspections and do assessments on pipes for clients with partners like yourself, Cassie, and then actually bring to the table some pretty interesting solutions at the same time. So, sometimes we get questions about that being a conflict of interest, but what that does is that really gives us the best kind of basis and knowledge of what these inspections cost compared to what the rehabilitation stuff costs. So we can really have a different conversation with clients and evaluate both sides of it. So if it makes more sense to do an inspection to try to really focus those rehab efforts in a specific location, say you've got a 2 or 3 mile alignment, and you can figure out that you've only got 1,000 or 2,000 feet of that 10 or 15,000 feet that needs to be rehabilitated, it really can create some efficiencies and some pretty dramatic cost savings for clients. So I think it gives us a little bit of a unique perspective that many of the other companies out there don't have. So today, I mean, I could go through just, step by step by step by step through all the different components and details related to the BulletLiner system, but we just recently completed 2 24-inch projects that I thought I would just share some of the photos and talk through the product at the same time that I'm just sharing some of the job site photos and details from the projects that we completed, so that people will get a real good understanding of what this looks like in the field and how the piping system works and how the fitting systems work, as opposed to just kind of going through the details. But just to kind of start, so I'll just pull up the first slide with some of the photos. There we go. So for anybody that's not familiar with FFRP, and just to back up a little bit, one of the other exciting things, now that this system has been around the world for about 20 to 25 years, and the product we're using has been in the marketplace for about 10 years now, they're starting to develop ASTM standards, AWWA standards. So for the engineering community, that's exciting because there's some guidance and some standards being created that really encompass all the different FFRP manufacturers and systems out there. So I think that'll be really helpful moving forward as they're doing designs for projects and trying to bid out projects. Now, most of the projects we've done over the past 10, 12 years haven't been bid out, but that's a kind of a preferred method of delivering projects in a lot of the country. Out in the Southwest, we do a lot of job order contracts, construction management at risk contracts, on-call contracts. We use co-op buying agreements, so it keeps a lot of this stuff from actually being bid out, since there aren't a whole lot of options, which is kind of exciting and interesting. But the basis of the system, flexible fabric reinforced pipe is basically made up of 3 different components. So you have an inner layer that creates the pressure component, which is a woven fabric, and it can be either polyester, it can be Kevlar, or it can be a combination of polyester and Kevlar or aramid fabric. So there's different properties to the 2 different types of materials. So the polyester is a little bit more flexible, but not as strong. The aramid fabric is much, much stronger, but it's much more brittle. So there's pluses and minuses to how you make you combine those different types of materials, depending on the design conditions of the project. So you basically have that interwoven core that's a seamlessly woven system that's continuous. Then you've got a modified polyethylene jacket on the outside of the pipe. You've got a modified polyethylene liner on the inside of the pipe. And the way our product is actually manufactured is that jacket and that lining system are actually embedded through the weave. So it creates a much higher tensile strength for the BulletLiner system compared to other systems that we've used in the past, which we think is really exciting. So the importance of that, if you look at the picture on the top left where we've got a cable put through the pipe and we are pulling it into the pipe, that means we can put a lot more pull force on the pipe due to the higher tensile strength associated with the pipe. So the other thing that's really exciting about the BulletLiner system is the size ranges. So in addition to being available for lots of different media types, we also have a much broader size range than we used to have with the system we've used in the past. So this system actually goes from 2-inch diameter all the way up to 48-inch diameter. So, we were limited to about 18 to 20 inch in the past, and it only went down to about 6-inch. So this just opens up so many more doors for large diameter pipeline rehab. Traditionally, if you got up over 20 inches, there weren't a whole lot of options from like that 20 to 36-inch range. So this kind of fills that gap, I feel, in the marketplace for doing long distance pulls through through bends and long radiuses and different things like that, where in the past you were really limited to distance when you got into bigger diameters.
So Chris,
And
one of the
yeah,
questions that I have is, you know, we see a lot of CIPP, not just in pressurized pipe, but in stormwater, but specifically in pressurized pipe. How does this differ? I mean, the install method for one versus CIPP, but also the pressure ratings and handling the 90-degree bends and things like that.
so what's different about the installation method, typically, and I'm no expert on CIPP, so I know just about enough to get in trouble talking about it probably. So if there's a bunch of CIPP experts on here, you know, don't come after me.
I'm in the same boat with CIPP.
Yeah, but if you're looking at it from like a general perspective, what's unique about a flexible fabric reinforced pipe, you know, everything's finished. So the way you see it here in these pictures, it's a finished product when we ship it from the factory to the job site. So there's no QA, QC. You don't have to mix up the resins and saturate the lining system and, you know, pull it into place and then cure out that lining system, whether it be from like a hot water or a hot steam system, or even a UV light type system is required to finish those other CIPP type products. So this comes finished. So there's very little QA, QC in the field, which is why it's had such success internationally. To my knowledge, there's never been a failure on a FFRP system internationally. So, and that's, you can't say that about a whole lot of pipe products. You know, pick any type of pipe, you know, you've got joints every 20 feet, or even in a CIPP system, you've got this curing process. So as far as pulling the liners into place, the process is similar. Both liners would be pulled in. It's just this system, if you see, is folded up in half and then taped. So all we have to do is literally pinch off the ends like you see in the bottom left photo. So we'll put either a roller clamp on the end of the pipe, or we'll put a plug on the inside of the pipe after we open it up. And then all we have to do to get the pipe into position inside the existing pipe is put air pressure on it. So once we put air pressure on the pipe opens up. Our pipe is actually designed to go right up against the interior wall of the host pipe. So there's some advantages to that as well, like being able to combine our independent operating pressures along with the host pipe pressure. So for example, we might only have an independent operating pressure in our system of say 150 or 250 PSI. But if we put that into a 750 PSI pipe and we put our lining system right up against the pipe wall, the two pipes act in conjunction with one another to give you a much higher combined pressure rating. So CIPP, on the other hand, is also designed to be pressed up as close fit to the existing pipe as it can be once it's opened up. But it's only typically designed to handle the live loads and the static loads over the top. And it's not necessarily designed for pressure. And the pressure systems that are out there for CIPP, the distances are limited because you can't pull it around like a 45-degree bend. It has to stay straight. And then also the pressure ratings are pretty low for most of those systems. So for example, you might have a 12-inch FFRP system like the BulletLiner system that could be rated from, you know, 250 to 500 PSI, whereas the same CIPP pressurized system might only be rated to 100 to 150 PSI, depending on the design. So I think those are some of the big differences. The distances you can pull the liners into place, the pressure ratings that are available for the different systems, and then the ability to pull through bends or not pull through bends. So those are the key differences, I think, between like an FFRP and a typical CIPP system.
Okay.
Does that answer your question, hopefully?
How many years has CPM been installing the FFRP system?
Yeah, I'm figuring out the question and answer thing, so I'm starting to see them pop up here.
Oh, you are, okay.
Yeah. So I'm new to this format, so I'm trying to learn here with you. But yeah, we've been installing the FFRP systems for, gosh, close to 12 years in the US now. So, and like I said, we've probably done close to 100 projects. With the BulletLiner system that we just launched in the last 6 months, we've already completed like 3 or 4 projects, and we've probably got about a half a dozen projects on the water right now that will be getting installed here in the next couple of months, and lots more behind it. So back to kind of the process here with some of the photos I have. So as you can see on the right side, that's the liner rolled up on a reel. On the bottom left, that's where or on the top left rather, that's where we've actually pulled the liner into the pipe. This specific project was underneath 2 irrigation ditches that we went underneath of. So we had 4 45-degree bends from pit to pit, and the pits were about 200 feet apart for each one of the installations we performed. So once we pulled the pipe in, we opened the liner up flat, and you can see in the bottom left picture, once we pinch that off and we attach an air hose, which you can kind of see right next to the roller, there's an actual air fitting that's connected to the liner. So that allows us to inflate it, open it up round against the interior pipe surface, and we don't have to keep it inflated very long. And you typically put somewhere between 15 and 55 psi of pressure on the liner to open it up, depending on which kind of liner system, which manufactured system you're using. So let me see if I can switch the.
This is a question that I have asked you before, Chris. Will the pipe collapse if it's not under pressure? It's a great question, because I had the same question last week.
Yeah, so the pipe will not collapse if you take the pressure off of it. I'll try when we get done kind of showing some of these slides. I've got an example of a 4-inch liner that's opened up inside of a pipe, a sample pipe I have, and if I can get it to show up on the screen, I'll show it to everyone. But yeah, once the pipe's opened up, it wants to go back round, and it's very rigid. So if you open it up inside the hose pipe and you round it out fully, like you saw in the previous pictures, the pipe, if you take pressure off of it, will not collapse. Now, if you put a hard vacuum on the pipe, it could collapse the pipe temporarily, but then if you put pressure back on the pipe opens right back up. I like to kind of point that out, because if you look at other material types, because that's a question we get asked a lot, and they'll ask about the FFRP systems. So like PVC pipes, for example, like C900 or Schedule 40, Schedule 80 PVC, HDPE pipes, none of those pipes are actually designed to handle vacuum. Now, will they take a little bit of vacuum before they'll collapse? Absolutely. And steel pipes are the same way. You can put a hard vacuum on a steel, and we've all probably seen pictures of steel pipes collapsing under vacuum. The big difference between the steel pipe or the PVC or the HDPE pipe is you can't put it back into its original shape. So once you put a hard vacuum on it, it exceeds its yield point and it's permanently deformed, and you can't go back. So with our system, if it were to be vacuumed, if you put pressure back on it, it'll go right back into its original shape and operate just like it was previously. So these pictures just show the fitting installations. So once you get the liner pulled into place, you open it up. We put a flange adapter. So in the bottom left photo, you can see an MJ by flange adapter kind of on the right side of the photo, and that's attached to the 24-inch ductile pipe. We bolt our back piece to that fitting, to that flange adapter to anchor it into place on the hose pipe. And then we insert a push fitting into the front that basically is a flange by flange fitting with an internal piece that goes inside the liner. And this is a compression style adapter fitting. So we then hook up a hydraulic press. So we put rods in it, we rod it to the back, we hook the press up to the front to a plate, and then we basically just engage the hydraulic press after we get everything lined up perfectly. And then it real quickly and efficiently just presses those two fitting pieces together. So this is pretty unique. It's a real simple process that doesn't require, epoxies or pumps or any type of curing system. It's also just a real simple 2-piece fitting, so there's no collars or other things associated with it. So once you press those two pieces together, you can put that pipe right back in service and bolt it to your closure piece to the other side, to where either your other piece has been relined or you've got your existing pipe still in place. and put the pipe right back in service as soon as the fittings are pressed together. So that's pretty unique. The other thing that's different between this and other systems when it comes to the mechanical compression fittings, there's more of a process to be completed with the systems we've used in the past, to where you have to actually inflate the liner. You have to start putting the fitting together. Once you put the fitting, or once you get the fitting mostly put together, you have to re-inflate the liner to bolt the fitting back to your back flange adapter. So that all takes a lot of time, especially if you've got a really long run of pipe that takes a long time to inflate back round again, or to put pressure back on. So sometimes it can take much longer to install other FFRP systems versus this simple BulletLiner hydraulic pressed termination fitting system. So these are just some other, quick photos we had of the fitting system, just to kind of give you an idea, a little bit more of what that looks like up close. But like I said, it's just a real simple hydraulic press. You bolt it all together, so that allows you to press the two fitting pieces together. And then once you've completed pressing them together, you're complete with the project. You have to go to the other side, press the other fitting on, and then the lining system installation is complete. So once this is done, generally, like we air pressure test the liner system, obviously, when we install it prior to putting the fittings on. So that's normally our main way to check to make sure the liner wasn't damaged during installation and nothing had happened to it. A lot of times clients will still want you to do a hydrostatic pressure test using water once the two termination fittings are on, and that's real simple to do as well, and doesn't put the liner under near as much stress or strain as what an air pressure test would. But it's always a good idea to go back and hydrostatic test it as well once you're complete. So just to talk about some of the technical details, just real quick. All our solutions are engineered solutions. We have a review process with the engineering department at the factory that goes through all the details on the project prior to us putting a proposal together and offering a proposal on a project. We work very closely with our internal sales team, our agents and partners like yourself, Cassie, and Reline Solutions, as well as a network of contractors around the country that we're working with. The factory is ISO 9001 certified. The manufacturer we work with has over 50 international patents for different types of materials and products that they produce. And then there's a pretty stringent QA/QC process associated with it as well. So we'll actually lay out and test every single liner before we reel it up and send it to the job site.
And to add to that, just so everyone on the call knows, what some people might be familiar with Michael Rothenberg or myself. Michael's based in Denver. He's a sales rep for us. We come out essentially as consultants, and we can look at projects. Obviously, we can offer the inspection tool that Chris offers to inspect pipes. But really, we want to give you guys different solutions for different problems. Obviously, if it's a pressurized pipe, this would be the only tool in our toolkit. But this is why we're bringing Chris's product on.
So I saw a couple more questions come up.
Yep.
Have you ever lined a sewer force main with the product? Yeah, with the first, probably the first 50, 60 projects we did over the course of the last 10, 12 years were water main projects. But more recently, force mains have become a much hotter topic around the country for everybody, really, because people are having problems. They're reaching the end of their useful life. So we've done a lot of sewer force main projects. There's just a couple of things you have to take into account. Obviously, you need to take into account the hydraulic profile of the pipe. At the end of the alignment, you generally want to try to keep the pipe full if possible. You want to make sure air valves are in the proper locations and providing vacuum relief and air release. So those are some of the other considerations on a sewer force main, but no, it's a perfect system for sewer force mains, same as water mains and really anything with pressure pipes. So the other question, or next question coming in, briefly describe the cleaning process prior to installation. Fortunately, the next project we have on our list that we're going to be completing is on a PVC C900 pipe. What's great about C900, you don't have all the heavy buildup and tuberculation. So those projects generally require just a soft foam pig to be pushed through the pipe and remove any sediment in the bottom. Now, if you get into something like a force main, we generally have to use either spring-loaded scrapers or other steel brush type scraper pigs. So we've also used rotating hoses to clean pipes, which are for larger diameter, using like a jetting system. We've used jetters and cutters and reamers on different applications, depending on how heavy the buildup is inside the pipe. And we're only trying to remove anything sharp. So it doesn't matter if we have a little like mud or dust or debris or something in the pipe, as long as there's nothing sharp. And we try to, and we do a CCTV inspection once we complete the cleaning to make sure that the pipe's suitable for the lining system. Yes, this liner is NSF 61 certified. The other system that's been prevalent in the United States is also NSF 61 certified. So really all the systems that we've worked with in the past have been NSF 61 certified for potable water applications. So yeah, perfect for any application you have, whether it be a water main or a sewer force main.
Any other questions out there? Will the BulletLiner minimize the number of pits needed for a CIPP or other slip lining process?
Yeah, we actually, there was a project, there's an active project that we're looking at right now that's a large diameter project that was initially looked at as a CIPP system. And it was only about 4,500 feet of pipe. That project initially as a CIPP pressure pipe project had about 15 pits because of limitations with the light trains and the UV curing systems and the ability to pull the liner once it's fully wetted out based on the weight. So that project had about 15 pits. We redesigned the project, basically cut the cost of it by over 50% and only required 4 pits to do the same project versus 15 pits.
The next question came in about bends again. Maybe talk about all the different bends and angles that BulletLiner can go through, because I think that's one thing that's hard to maybe wrap our mind around sometimes.
Yeah, so as a general rule, we can go through a 22.5, a 45, 90s, or upon approval by the manufacturer. So generally speaking, if you've got a 90-degree bend close to one end or the other of the alignment, you can oftentimes pull through a 90, and then also you could even downsize your liner to some degree to allow you more clearance coming around to 90. But we've actually got some videos that show liners pulled in through long radius 90s, which would be like a 5 diameter 90, and that we can pull the liner through with no problem. But those aren't typical in a water main. Usually you've got like a 1.5 diameter 90 and they're very tight. So it's kind of limited, but a 45 you can do all day long, which is pretty common.
Can you use this liner for bypassing if the conditions allow it?
Actually, we've got a much more flexible, so the modified polyethylene that we use on our basic W type BulletLiner is really stiff. We've got a separate system called MildFlex. It's a BulletLiner MildFlex system that's more flexible and it's perfect for bypass. And we can put that on roughly 700-foot reels with stores connection, anything from 4-inch all the way up to 16-inch. And we can roll out like 700 feet at a time bypass in literally a matter of minutes compared to laying out HDPE pipe and fusing it and connecting it. So we can do it much, much quicker. And we have those options. And then the other question about the footprint, each pit location, and we can spread these pits out. If we can get the cleaning accomplished and the camera work accomplished, in theory, we could spread these pits out a mile apart or more. Sometimes you're limited on your cable lengths and your camera abilities and your tagline, being able to pull taglines through. So 2,000 to 3,000 foot shots is typically more manageable. And then each one of those shots would have termination fittings and pits on each end, and those pits are generally about 10 foot by 10 foot by however deep you need to get a foot under the pipe.
I think that is it. That is like perfect timing, right at 10 a.m.
Perfect.
All right, you guys. Well, I noticed that we had quite a few engineers on the call today. If any of you want or need a PDH credit, I know it's only 30 minutes. It's not a full hour, but I'm happy to send you that certificate. So just shoot me an email. Let me know if you need it. Otherwise, you've got my information. If there's anything that I can give you to Chris, if you have questions that I can't answer, or Michael's on the call and he'll be following up with some people as well, we're happy to help.
Thanks, Cassie.
Oh, last thing to note, we're going to do a separate Reline Live on just the inspection tools. That was one that I just felt like we'd be trying to put too much into this one. So we're going to have a separate one that's just going to cover all the different inspection tools that we can offer to municipalities to run through the pipe and actually get a full 360-degree picture.
Perfect.
All right. Thanks, guys.
Thank you.
All right. Bye.
Bye.